Assalamualaikum warahmatullahi wabarakatuh. Today, I will present my research title, The Causal Impact of Health Expenditure, GDP per capita, sanitation facility, and urbanization on life expectancy. This research analyzes how various socioeconomic factors influence life expectancy, a vital measure of a nation's health and progress. Let's dive into the details. Life expectancy is a critical measure of a nation's overall health and development. However, many developing countries face significant challenges, such as limited access to healthcare, inadequate sanitation, and insufficient resources. This study focuses on understanding how these factors, along with GDP and urbanization, impact life expectancy. While there is substantial research on public health, few studies provide a comprehensive cross-country analysis of these factors. Understanding this relationship is crucial for policymakers to allocate resources effectively. This study used 2018 data from 50 countries to address this gap. My objective is to identify the key factors that influence life expectancy, quantify their impact, and provide actionable insight for improving public health outcomes globally. From my research, it consistently shows that improved sanitation reduces disease and significantly increases life expectancy. Healthcare spending positively correlates with life expectancy, but its efficiency varies by economic content. GDP enables investment in health, but is moderated by factors like pollution. Urbanization enhances access to healthcare, but issues like overcrowding can offset its benefit. The dataset includes 50 countries from 2018, with life expectancy at birth as the dependent variable. The independent variables are sanitation access, healthcare spending, GDP per capita, and urbanization, all sourced from the World Bank. I used a multiple linear regression model to quantify this relationship, with Y representing life expectancy and X1 to X4 as independent variables. Rigorous data cleaning and validation ensure accuracy and reliability of the model. Descriptive analysis highlights key patterns in the dataset. The mean life expectancy is 75.19 years, showing relative stability across countries. For sanitation, the mean is 81.74%, with a left-skewed distribution due to some countries with limited access. Healthcare spending averaged 6.68% of GDP, distributed consistently worldwide. GDP per capita shows significant disparity, with a mean of 2.65k USD and a right-skewed distribution influenced by wealthier nations. Finally, urbanization has a mean of 56%, indicating that more than half of the population in most countries reside in urban areas. The correlation analysis reveals strong relationship between life expectancy and sanitation, with a coefficient of 0.86. Healthcare spending and urbanization also show moderate positive correlation at 0.6 and 0.67 respectively. However, GDP per capita has a weak negative correlation of negative 0.21, indicating that economic growth alone may not directly improve life expectancy. The variance inflation factor (VIF) Analysis confirmed that the model does not suffer from multicollinearity, as all values are below the threshold of 5. The highest VIF is for urbanization at 2.04, which is well within acceptable bounds. This ensures that the independent variable contribute unique information to the model without excessive overlap. The regression equation shows that all independent variables positively impact life expectancy. Sanitation has a coefficient of 0.18, while healthcare spending contributes more significantly with a coefficient of 0.64. Urbanization has the largest effect with a coefficient of 3.49. GDP per capita is a marginal predictor with a coefficient of 0.49. The R-square value indicates that the model explains 83.42% of the variance in life expectancy. The residual variance, 8.1, reflects the variability in life expectancy that the model cannot explain. This impacts the precision of the slope coefficient. Sanitation has the smallest variance at 0.00028, indicating high confidence in its effect. Healthcare spending and GDP per capita have moderate variance of 0.02096 and 0.03615 respectively. Urbanization with the largest variance of 0.65735 shows the most uncertainty. High residual variance generally reduce the precision of estimates, particularly for urbanization. In contrast, sanitation shows the most reliable and precise effect on life expectancy. In hypothesis testing, we evaluate whether each independent variable significantly impacts life expectancy. For sanitation, the p-value is 1.49 times 10 to the power of negative 10, making it highly significant at all levels of 1%, 5%, and 10%. This confirms its strong positive effect on life expectancy. Healthcare spending has a p-value of 0.002, showing significance at all levels, reinforcing its critical role in improving life expectancy. Urbanization is also significant at all levels, with a p-value of 0.0059. This highlights its contribution to better health outcomes, likely due to improved access healthcare and infrastructure in urban areas. For GDP per capita, the p-value of 0.0567 is only marginally significant at the 10% level, indicating its influence is weaker and less reliable compared to the other variables. In conclusion, sanitation, healthcare spending, and urbanization are robust predictors of life expectancy, while GDP per capita plays a more limited role. The 95% confidence interval further validates the results. Sanitation, healthcare spending, and urbanization have entirely positive intervals, confirming their significant and positive impacts on life expectancy. However, the confidence interval for GDP per capita includes 0, reflecting its weaker and less reliable influence. The goodness of fit for this model is represented by R-square and adjusted R-square. The R-square value is 83.42%, indicating that the independent variables collectively explain most of the variation in life expectancy. The adjusted R-square, which is slightly lower at 81.95%, accounts for the number of predictors and adjusts for overfitting. This ensures that the model does not include unnecessary variables that do not contribute to explaining the dependent variable. The high values of both R-squared and adjusted R-squared confirm that the model has strong explanatory power and strikes a good balance between complexity and accuracy. This indicates that the chosen predictor, which is sanitation, healthcare spending, GDP per capita, and urbanization, are highly relevant for explaining life expectancy. Removing urbanization from the model results in significant change in the coefficient of the other variable. For instance, the coefficient for healthcare spending increased from 0.64 to 0.78, while GDP per capita drops from 0.49 to 0.22. This highlights the interdependence of the variables and the importance of urbanization in the model.